In this problem, we're asked to compute the 1 ohm energy content of the signal Vi of t as e to the minus 2t u of t volts in the frequency range from 0 to 1 radian per second. And we're going to use Parseval's theorem, okay, which says the integral from minus infinity to plus infinity of f squared dt is 1 over 2 pi integral from minus infinity to plus infinity of the magnitude of f of omega squared d omega. Okay, so Vi of t is e to the minus 2t u of t volts. So then Vi of omega is 1 over 2 plus j omega. The magnitude of Vi of omega then is 1 over the square root of omega squared plus 4. So the magnitude of Vi of omega squared is 1 over omega squared plus 4. Okay, so now, using this Parseval's theorem, we have W is 1 over 2 pi integral from minus infinity to plus infinity of the magnitude of Vi omega squared d omega. Okay, now, since this is a even function, we can go in and double this and only integrate over 1/2. Okay, so we doubled it and integrating from 0 to infinity. So now we have 1 over pi. Here now the integral is 0 to 1 over omega squared plus 4. So when we integrate, we'll have 1 over pi times 1/2 times the inverse tangent of omega over 2, evaluated from 0 to 1. So we have 1 over 2 pi. We have the inverse tangent of 1/2 minus the inverse tangent of 0, which is 0. So if you go through and calculate, then this turns out to be 0.0738 joules.